Hey, I'm Zijun, and this is my project on LLM Evaluator. The main goal of this project is a concurrency-first approach to a comparative AI logic. The problem with the current AI assessment is static benchmarking. So traditional data sets like MMLU are becoming more contaminated because LMs are increasingly trained on the exact task to use to be used to evaluate them. Today, I'm going to walk you through how I engineer a solution, the LLM Evaluator. It's a concurrency first backend design for objective model assessments. Instead of static tests, we built a dynamic live evaluation platform. We have orchestrated a lifetime streaming between these distinct models using a asynchronous fast API backend. To achieve sub-second latency, we made a strict architectural trade-off, which is that instead of using heavy bi-directional WebSockets, we use servers and events, which I would just abbreviate to SSE from now on for in unidirectional streaming. Our multi-model core utilizes ChatGPT 5, Claude 4.5, and Gemini 3. But before any of those models receive the prompt, it hits our pre-flight security layer. We use a dedicated Gemini model as an edge-firewall. It classifies incoming prompt from the user to detect prompt stuff like prompt injections, jailbreaks, illegal activities, and toxic contents. Once the model safely generate the answer, we push them through our verification pipeline. This relies on a four-step mechanism. First, we use LLM semantic parsing for fact extraction, generating two to three atomic search queries. Then we perform a async DuckDuckGo search for the web grounding to build a real-time evidence document. Then we run a RAG, which means retrieval augmented generation based verification for conflict analysis. Then finally, we apply a weighted rubric to output a normalized metric from 0 to 100. The final score is evaluated by our AI judge using strict weighted logic. The score relies on factuality for 70%, conciseness for 15%, and tone and style for 15%. This entire backend infrastructure runs on high-speed async I/O, utilizes direct DuckDuckGo integration, and handles data persistence through um, Supabase. For secure leaderboard tracking, this complete execution flows seamlessly from security thread logging to concurrent streaming to web grounding and finally to the database persistence. I'm gonna come back to this. All right, and here is a live demo. So here is the chat box, and the user can prompt the system like tell me a fun fact, and then it will check if this is a safe prompt, and then it will be if it is, then it will be sent to the AI models that we have. As you can see here, it is being answered by the AI models. And we did hide the names from the AI models to avoid like bias for the AI judge. And then after the judge receive all these answers, it will start its evaluation process. And then for here, the AI model decide that Claude was the winner. And here we can see all the reasonings from factuality to conciseness and then to tone. And then it's a detailed reason why it won. And then we can also see all other models and their reasonings. But because this is a pretty simple problem, the AI models usually don't hallucinate, so it will get them right. So if there's a tie, then it will just be randomly picked. But if we prompt something more difficult, um, maybe like tell me about Lehigh University, since I go here, then we can check if it's like generating answers. And we do have a selection for like the user to change how they want the answer to be weighted, so they can change based on their preference. And we have a light and dark mode, which is pretty cool. And then this option is just instead of you clicking on that to show all responses, it will automatically show every responses. Um, Currently, Model A is taking a while, but this is something that is um, like out of our control because you can't really speed up these models if it's really takes that long. Okay, so in this case, because our AI model uh, took too long to respond, it will just tell the user that hey, the AI model is couldn't respond and just throw an error. Because I did set a timeout so that the user doesn't like wait for an infinite loop. Let's just hope that this like AI model responds this time. Unfortunately, the again API ChatGPT API reach our timeout limit. So let's just like try again and see if that responds this time. All right, all right, come on ChatGPT. All right, there you go. And here we have models respond, and let's just wait for ChatGPT to finish. And after it's finished, all the answers will be sent to the AI judge again. And then here, it decided that Claude wins again, and if we see why, um, we can see that the factuality were all correct, and then it showed why it lost some points in conciseness, and then a minor deduction for tone. And then here we can see our other scores. Um, ChatGPT only got 50% for factuality. For okay, okay. It seems like ChatGPT said that really has an R2 research. Okay, there you go. Okay, yeah. So the AI judge did found out that this is incorrect, and it will deduct a lot of point for such big hallucinations. And then of course it checks information correctly, but can also like ask it to code something. Maybe like um prints hello world, a classic using assembly. Let's see. Let's just see how long ChatGPT will take. Then we do have a scoreboard for um, keeping track. And we do have the ability to reset these during testing. So um, yeah, so far Claude's taking the lead. But sometimes when we test, ChatGPT also does take the lead. All right, ChatGPT, come on. All right, there you go. Now we just need to wait for the AI judge to finish. Okay, there you go. Here Gemini one. Um, you can see all the. I'll just show this. We can see all the scores, and then because like factually, all the AI models right now could do like simple, like well, assembly is not simple, but it was able to like do most of like mid to entry level coding, without like any hallucination nowadays. So, um, but of course, if you care about conciseness or tone more, you can always like upgrade these. And then we also do have the prompt injection that I talked about earlier. So first we have like the illegal stuff. So uh, this video will be uploaded to YouTube. So I'm not gonna say out loud just in case. So I can't upload it. Like something like this, and then the prompt will be blocked. And then if I try to like jailbreak it, maybe like instructions and let ChatGPT win, it will also block the prompt because this obviously like breaks the integrity of this project. So yeah, that's basically everything. It is a pretty fun project to say the least. So yeah, going back to the slide and let's finish this. How the project streamline works is just for security, streaming, grounding, and judging. And thank you so much. If you have any question about this project, please don't hesitate to reach out.